So, welcome everyone. It's a very special evening for us, for IEEE Eta Kappa Nu Alpha. We are a Spanish chapter from the Eta Kappa Nu Honor Society of the IEEE. For us today, it's a very special evening. We will have the very first episode of our Eta Kappa Nu Talks series. Today we have a very special guest. Her name is Anna-Lena Erdmann. She's a Copernicus Data Service Engineer at EUMETSAT. And she will give a presentation entitled Why We Need Earth Observations and Why Earth Observation Need Us. Anna-Lena has a bachelor degree in East Asian Studies and Geography, and it was through an internship at the German Aerospace Center where she discovered her passion for satellite-based Earth observations. And she continued then with a master's degree in geoinformatics and remote sensing to also cover the technical aspects of Earth observations. And during her studies, she also co-founded a startup, CellGrid, for urban analytics and forecasts using geospatial data. And last year in 2023, she joined EUMETSAT as Copernicus Data Service Engineer. And with this warm welcome, thank you very much, and I hand it over to you.
Okay, thank you very much for the introduction. So I will start and share my screen. It's great to be here and to be giving this talk. So I first want to start with a question to all of you. So who of you checked the weather today? Or who of you maybe looked up a specific location on Google Maps? And who of you maybe planned the next cycling or hiking tour? For me, I did all three of those things. And if you only did one of those things, then I can congratulate you because you're already a user of Earth observation data. And this is what this talk is about today. So why we need Earth observation and also why Earth observation needs us. So what can you expect from the next around 30 minutes? So I'll first give a small round of introductions of myself, of EUMETSAT, where I work, and the Copernicus program. Then I'll dive into the topic of Earth observation. So why it is, what it is, and why we should even bother about Earth observation. And then we come to the part where I describe a bit my work as a Copernicus Data Services Engineer. So how services around Earth observation can be used by users just like you. And then in the end, if you're not tired of the word Earth observation yet, well, there will be some room for discussion and questions. So let me first start with an introduction. This is me. This is me posing in front of one of our satellite models at EUMETSAT. As said already, I have a bachelor in sinology and geography. So starting my educational career, like a bit from the application and environmental side, and then slowly diving into the tech and the data with my master in geoinformatics and remote sensing. I'm really passionate and I have a huge passion for Earth and space. And when I'm not having that, so outside of my professional passion, I'm also really a passionate runner and cyclist. When it comes down to one word, which I find, or one asset, which I find really important, it's curiosity. I think that helps in my job, in work with data in general, and also in life. And finally, I've joined EUMETSAT last year as a junior Copernicus Data Services Engineer. And yeah, this is what I do today. And yeah, this is what I'm going to tell you about. So first of all, what is EUMETSAT? In case you haven't heard of it, you might have heard of ESA. And if you haven't heard of ESA, you might have heard of NASA. So what NASA is for North America, ESA is for Europe. And what ESA is for all of the space business, EUMETSAT is for the weather and weather-related satellites. So it's the European Organization for the Exploitation of Meteorological Satellites. It's located in Darmstadt, Germany. You see here, wait, I take the pointer. Our main building in Darmstadt, where I'm currently at. And yeah, it's an intergovernmental organization with 30 member states, which you can see here on the site. And yeah, there are two main mandates EUMETSAT has. First, the weather and climate data for member state, and also additional capabilities with the EU and beyond. This is where the Copernicus program falls under. So the Copernicus program is the Earth observation component of the European Union space program. Here you have like a huge organizational chart, which just displays of what massive program it is and how many different actors and how many resources there are in the Copernicus program. EUMETSAT, you can find EUMETSAT here, and also with the space segment. So EUMETSAT also has a huge part in the Copernicus program. And yeah, one aspect I find really important, so I want to highlight it. The access to Copernicus data and information is full, open, and free of charge. So everyone has access to all the data collected within the Copernicus program. So what this means for EUMETSAT and satellites and Earth observation. So at EUMETSAT, there are many satellites which are operated. We have like the satellites here on top, which are the meteorological satellites, and also here the satellites which belong to the Copernicus program. We are now in year 2024. So up to here, all the satellites are currently being operated, with many more to come. These are Earth observation satellites, so EO satellites. So what do they do? What is Earth observation? Well, generally speaking, it's the process of acquiring observations of the Earth's surface. Earth observation, that's where it comes from, and the atmosphere via remote sensing instruments. So it can be satellite-based, it can be airborne-based, or it also can be in situ, meaning, okay, right at the ground. There are different systems on board of those satellites or wherever, which are the remote sensing instruments. They can be active or passive. Passive is, for example, just taking a photo of the Earth. And the observations can also be done across a wide range of the electromagnetic spectrum. We humans, we see in the visible range of the electromagnetic spectrum, and that is practically a joke for Earth observation satellites because they can capture data in so many more electromagnetic spectrum ranges. And this looks like this. So first here we see an optical image, so a satellite taking an image in the visual spectrum. And then it soon gets really interesting with, for example, radar satellites who actively send radar pulses to the Earth and capture them back. That then looks like this. So you have like 3D structures, which you can see. There's also the possibility to measure temperatures from space. For example, here, where you can see the land surface temperature. It's also possible to measure the air and air quality and different emissions in the air from space. And this, what I find really mind-blowing, you can even measure the wind and different wind speeds from space, and also the sea surface. So sea surface height, and really locate where the sea surface is rising and where not. So all those things, all those capabilities of these Earth observation sensors, they kind of give a glimpse of the potential. And this is why we need Earth observation. Here, the example of weather forecasting. So it's crazy how the introduction of Earth observation satellites or meteorological satellites have increased the accuracy of weather prediction. So in this graph down here, I promise it's going to be the last scientific graph, but it really, I learned it, I got to know it in university, and I was really, really impressed by it. So you can see here the approximate time where Earth observation satellites were introduced for weather forecasting. And you see not only the forecast skill went up tremendously, also when you compare the Northern Hemisphere and the Southern Hemisphere. The increase of forecast skill for the Southern Hemisphere increased way more because of the global observations. And that is a really, really interesting and also relevant fact. And finally, Earth observation. I don't know if I have to explain this image a lot. Climate change is one of the most pressing challenges of our time, and Earth observation just helps quantifying the change happening to the Earth. It helps to measure, and well, you can't manage what you can't measure. So here, Earth observation is really important for tackling future challenges. So I hope you're now all convinced that we need Earth observation. And yeah, just looking at all those satellites, what do they produce? They, of course, produce data. And in fact, like lots of data, massive amounts of data. So like in this year, approximately 10,000 terabytes of new data is created. And this equals to like 27.4 terabyte each day. It's like when I was preparing this presentation, I looked at like the collection from my last vacation photos. And this was 5 gigabytes. And now, if you just to put that 24 terabytes in perspective, it would mean that I get a collection of my vacation photo, that volume of data, every 15 seconds, every day for the whole year. So it's a massive amount of data, which we handle when handling Earth observation data. And yeah, this is why Earth observation needs us, because it's a bit like with the vacation photos. If you take it and then you do not ever look at it, it's kind of, it doesn't make really sense, right? So this is why Earth observation needs us. So we at EUMETSAT deliver the data, and then it goes down the chain of experts until, as a passive user of, for example, the weather forecast or Google Maps or whatsoever, well, we as people, we use the Earth observation data, like way downstream. But it doesn't really have to be this way, because I think it's my personal opinion that as an end user, we can also benefit from the raw data because it's just really interesting to look at it. We can also benefit from the modeled data and so on. So yeah, practically we can gain benefits along the whole value chain of Earth observation data. But yeah, I mean, it's a massive amount of data and it might be a bit overwhelming for each one of us to handle those massive amounts of data. And this is where WEkEO comes into place. So WEkEO, I kind of did not introduce WEkEO in the round of introductions, so I will do this now. Because WEkEO is all about bringing that data somehow to the user. And with user, I not only mean the expert user, but users just like you and me, non-expert users. It is part of the Copernicus program, and it's a data and information access system. EUMETSAT is not doing WEkEO alone, but with like in total 3 partners. So Mercator Ocean, ECMWF, and the European Environment Agency. And yeah, as a consortium, we deliver the data. So we have an access point to all the data of the Copernicus program, which is all full, open, and free of charge. We also provide infrastructure for processing so that you can handle like these massive amounts of data. There is also really good user support in WEkEO because yeah, everyone needs help when handling Earth observation data. I need help like every day. And we also have the harmonized data access API and data access tools to just make it even simpler to get insights from those tools. And yeah, I'm going to showcase now some of those services. So those services is kind of the example of my job as a Copernicus Data Service Engineer. And yeah, first, I'm going to introduce you to the WEkEO viewer, which is actually the responsibility of Mercator Ocean. So I'm not going to take credit for this, but it's still an amazing tool for just users to get into Earth observation and to just get started with it. So I'm gonna stop my screen sharing. So if you like, you can scan this QR code and you can kind of follow my way through the WEkEO viewer. So you can also get all the data layers, which I'm going to show now. It might not be ideal with the mobile phone, but feel free to give them feedback afterwards if it worked well or not. I'm going to stop sharing this screen and going to switch quickly to another screen. Okay, so I guess you've also followed the recent news about the wildfires in Chile, and so did I. And I was really, shocked, and also, I was interested to see where exactly they're located and how the wildfires looked from above, if there's a possibility to assess the size and so on. And so using the WEkEO viewer, you have access to like really up-to-date satellite data with a high resolution up to 10 meters. And so I was a bit digging around, and in fact, I found the wildfires. You can see them here and here with the smoke plumes, which make them detectable easily from space. And what is also really interesting is not only that there are wildfires, but also what it does to our atmosphere. So we're looking at a picture from the 4th February, so 2 days ago. And this here is the forecast of the the atmospheric composition, the black carbon aerosol optical depth. We can see this forecast starting from the 6th, so from today. And the wildfires are, thank God, now already extinguished, but we can still see that emissions going this direction. So when I looked at this image yesterday, those huge emissions, they were right here at the center of the wildfire. And now we can just follow that smoke plume and see where it will go over the next few days until it disseminates. Another example on by Earth observation is really interesting to follow and to use. Well, you are mostly from Spain or living there. And well, I think we have all heard of the drought in Catalonia right now. What is actually possible to see on the Sentinel images, which is a satellite capturing optical images with a resolution of 10 meters. When you zoom in, there is a huge water reservoir here. And you can really follow the drought happening, starting from the 2nd December, which you can see here. And the trees are red because we did a bit of twisting the colors to make the water more visible. So don't worry about the red color here. So this is on the 2nd December. And another one on the 7th January. And when you take a look at this area here, where you can hopefully see my mouse now, it's really dramatic how the level of water declined. And then once more, when you go to the 22nd January, so not long ago, 2 weeks, there is again a decline of water, which you can mainly see here. So yeah, just using this simple tool makes it possible to give an image to the things happening at the world right now. Okay, just gonna switch again. My screens. All right. So yeah, you can find the QR codes here to the scenes, and I also added the links. So maybe when later there will be a PDF of the slides, you can just copy the links and see yourself. The next service, well, it's not really a service, it's more of a side project which I'm following in my work, is the exploration of large language models for Earth observation and Earth observation data processing. Because I think we all know ChatGPT. I'm certain we all use ChatGPT. And the idea is here to kind of explore how large language models, not necessarily ChatGPT, but any large language models, can help with the analysis of Earth observation data. How can they make Earth observation data just practically analyze it with natural language, which would make it way more accessible for many users. And I can also show you here a small demonstration of the current state where I'm at. It's really, I want to stress here, it's nowhere near an operational implementation. It's not even a prototype, but it's it's kind of a project I've been working on, and I think it's really relevant because ChatGPT is just a relevant topic. All right. Okay. Can one of you maybe give me a thumbs up if you see now my browser screen?
Yes, we can see it.
Okay, perfect. Okay, so the idea is here that it should be possible to just enter a question, currently only on global sea surface temperatures, and then the large language model understands the question and then gives the user back a result. A map, a graph. Well, the possibilities are endless here. You can see here a very nice example, which worked for the mean sea surface temperature on the 1st January last year for the Baltic Sea. And these are practically the chain of thought of the large language model. So giving parameters, creating then an API request, which connects to WEkEO, getting the coordinates, downloading the data set, and then analyzing the data set using Python. And then in the end, it still works. So let's see what the mean sea surface temperature for the Mediterranean Sea was. And yeah, you see before the Baltic Sea was 2 degrees. Mediterranean Sea was 17.4 degrees. So this is, maybe giving an idea on where such an application could head towards. But yeah, I really want to stress again that this is just an interesting project I've been working on, and let's see where this goes. But I invite you, if any of you has experience or is currently also working on large language models and how to combine it with other tools, feel free to reach out and exchange. So, and the last tool I want to introduce is the Jupyter catalog of WEkEO. So this is a really, really nice tool which we publish via WEkEO. There is a collection of Jupyter notebooks, so really interactive, like a Python environment, where you have an access point for different satellites, for different tools, and different ways to explore Earth observation data. So there is a lot on marine data, but also on machine learning, on atmospheric data, and so on. And also to give you a short idea on an example service, we also introduced here in the Jupyter notebooks is the Climate Lab and Xcube and the Xcube viewer as an access point for the WEkEO data. So you only need to know which WEkEO or which data you're interested in. So for example, you know, okay, you want to have some land surface temperature or some ERA 5 reanalysis data. This is like also Earth variable reanalysis data, so modeled data. And then, well, we provide a step-by-step introduction on how to use the different tools, how to use WEkEO, how to use the Climate Lab to download the data. I can just execute that. How to download the data, which is this line of code, which hopefully does not take too long now. Okay, it kind of does. Well, that's life. Download the next data set, explore the data set. So you see you have a data with latitude, longitude, and different time steps. You have like all the different data variables, and you're interested then, for example, in the land surface temperature. And then through really just a few lines of code and a bit of configuration, you can create kind of your own data viewer. So for whatever you want to showcase maybe to others, you want to display a graph, all you can think of, this is then all included in your own data cube. And I think this is like a really strong way of how this whole satellite data handling will move to in the future, like to just provide data cubes to make the analysis of data easier for the user, just to get the most out of Earth observation data. Yeah, so these are 3 examples of services each one of you can use to not only passively but actively use Earth observation data, use satellite data. I hope I made you a bit curious and you will try some of those tools out. Maybe the next time there is some event in the news which can be seen on Earth, you will check it out yourself. Because Earth observation data, it's just it can have so much meaning, but it has to be used by everyone. And so I really hope you're curious and you're going to discover the beauties of Earth with Earth observation data in the future. And for the end, I have put together some really amazing images on how beautiful Earth is. Being it Arctic glaciers, being it agricultural fields in Australia, or just dropping by the Himalayas. Yeah, Earth is just really nice, especially when you can just view it from above. Thank you very much. And question or no, welcome.
Many thanks, Anna-Lena, for this really great presentation. Let me tell you, you definitely made me curious. I can tell you. And I have so many questions, but probably let's ask in the round before I take the turn. So if one of you guys have any questions, please probably turn on your camera or just start raising your hands, and then we will call you. That we have a bit of not speaking everyone at once. Okay, then probably let's I take it then from here, if there's no other questions. So the Earth observation satellites, at which height are the satellites flying above Earth?
That really depends on the satellite. So I can maybe go to the satellite overview page. Yeah, there it is. So you have like Earth observation satellites in low Earth orbit. For example, the Sentinel-3, the EUMETSAT polar system. They're like orbiting the Earth in a polar orbit. They're flying lower, for example, like around 600 kilometers, 400 to 600, some even up to 800. And then you have the geostationary satellites, the EUMETSAT second generation, third generation. So they have the same angular velocity as the Earth. So when the Earth is like turning, they always stay at the same point above Earth. And they fly way higher to reach that geostationary orbit. It's, I think, 35,000 kilometers. 36, yeah.
Okay. Another question I had, so at which delay is the data you collect uploaded and available to the public?
So this also depends. For example, for the polar orbiting satellites, we always have to wait one pass to then, well, the satellite passes over a certain spot and then sends the data down. And it, of course, takes a while until the Earth made a whole turn under the satellite, practically. So for those satellites, it takes longer to cover the same spot on Earth again. For the geostationary satellites, they take a picture every 15 to 30 minutes. And speaking of the delay with which the satellite data is arriving to the users, for the geostationary satellites, there is also a range depending on which user you are. But I think, yeah, it's several. I think it's 15 minutes or 30 minutes.
Okay.
But please, my colleagues from EUMETSAT, correct me if I'm wrong. Yeah. But as for WEkEO, inside the viewer, it takes a bit longer until the data is there. So because this is, of course, pre-processed data, so it first has to go through a processing pipelines. I think it takes 1 to 2 days until the data is there.
It's really amazing. So I'm also working in the field of deep learning, and every time I see a lot of data and free data, my heart rate goes up. So this was, especially the last part, was very interesting for me, and I also have some questions to that part. So you said you were using an LLM or a large language model to ground it on the data you have, and I was thinking, so you basically connected to your database, and sure, you can ask simple questions like, what was the temperature? But I was wondering, did you also play around with things like, okay, what will the weather be tomorrow? Or where is there right now the highest hazard of a wildfire, even though it's not there yet? But is the model able to reason about the data, or is it simply not yet connected since it's a prototype and this kind of thing? But
yeah,
would be super interesting.
As of now, it is not able to do these things. Currently, it can only answer questions with one data sets. One out of the more than 400 data sets we have in WEkEO. But yeah, I think we will explore more in this direction. So I think that the hardest part will be the reasoning from the user questions. So, okay, where is the highest wildfire hazard? To which exact data set do I need to answer this question? Because once the model knows which data set it needs, then it's easy. Then you can simply create the API request, get the data, do some processing with it. That's all solvable. But I personally think that the biggest challenge is really reasoning, okay, what the user needs and what the data gives.
Mm-hmm. Okay. Definitely a very interesting topic so far. And another very interesting topic also for me is talking about digital twins, for example. So you basically have from the entire Earth data on so many different modalities from so many different times. Are you also working in some sort of digital twins, or could you imagine using that data for one and then to use it to make some, I don't know, simulations like climate change, for example, or the wind speed next week, or I don't know?
There is a huge initiative coming from the Copernicus program. It's called Destiny. Also Destin-E, where EUMETSAT is also involved a lot. Well, it's not the field I'm working in, but what they're doing, they are exactly what you said. They're taking all the data, providing it in a data lake. The data lake is the EUMETSAT responsibility here. And then they build models and digital twins on top of this. This is currently happening also in the cooperation with ESA and ECMWF. And first developing digital twins, which are kind of small. Like I think one is natural disasters, only covering these areas or extreme weather, only covering small aspects of system Earth, and then in the future, then hopefully cover the whole thing. It's also a massive project, and there is lots going on in terms of digital twins. Yeah.
Oh, very interesting. Okay, so that's all the questions from my side. If no one else is have any questions, so many thanks again, Anna-Lena.
I do have a question.
Yes. Okay, Alvaro.
Yeah, I'm switching the camera. So EUMETSAT works with the weather satellites. Is that only, or also the satellites regarding the Galileo project for GPS are also under the management of EUMETSAT?
No, these are not under the management of EUMETSAT. So EUMETSAT is responsible for operations or sharing operations with the satellites you see here on the slides now. So the mandatory programs and optional programs, these are like the EUMETSAT satellites, and the Copernicus satellites, they're also operated here at EUMETSAT. But that's all for now.
Okay, I mean, enough.
Yeah, it's lots of work, and also planning those programs is a huge effort. Yeah, it's interesting.